In today's lecture, we will discuss electron-spin orbit interaction, which is main cause for fine structural doublets. Okay, so many atoms like alkali atoms can show fine structural doublets. So this is the main reason behind that is spin orbit interaction. Okay, we know atom has electrons in its outer orbits. So this orbit, okay, this orbit and the electron's individual spin, okay, so electron's individual spin and its orbital motion, this interaction is the main cause for fine structure level or the splitting of main spectral line. Okay, so for fine structure, the main cause is spin orbit interaction. Now, here in this section, we will calculate the term value. Okay, the term value, the interaction value or interaction energy, then term value. So, of a fine structure doublet. So, we will calculate this. First, consider spin angular momentum. Spin angular momentum. Spin angular momentum S star h by 2 pi. Similarly, orbital angular momentum L star h by 2 pi, where L star as value S into S plus 1 L. So L star is same as S. So these are the values for S star and L star. So this is nothing but spin angular momentum for that electron, and this is orbital angular momentum for that electron. This one. Okay. So what is interaction energy? First we have to calculate interaction energy. Okay. Interaction energy. So what is interaction energy? So interaction energy is nothing but the change in kinetic energy of the system, of the atom, we can say, of the system's kinetic energy due to the precession of electron. We know this orbit, this electron spin here. Okay, so this interaction energy is nothing but the interaction between orbit and spin. Also, it mainly changes the system's kinetic energy due to the precession of this electron around the magnetic field. We know there is a nucleus. Okay, nucleus having positive charge. We know this electron has negative charge. So this electric field causes magnetic field. So the precession of electron around that resultant magnetic field is nothing but a interaction energy. Okay, so that interaction changes its kinetic energy. Or we can say we can say maximum energy. Okay, most of the energy is kinetic energy of this atom. So this energy changes due to the precession of this E bar along this H. Okay, it is a resultant magnetic field due to the electric field due to this nucleus or the whole atom. You can see here it is positively charged, it is negatively charged electron. So their interaction causes this magnetic field. So the precession of this electron spin around this magnetic field is nothing but a interaction energy. So we have to calculate this energy. We can get this orbital angular momentum from classical model. Classical theory as this L star h by 2 pi. We can write it as V know L R bar cross P bar. So this is another one, angular momentum, same as we have shown before. Okay, this is in classical theory. Okay, so where we know this is m for mass of electron, r is the radius vector of the electron, p is velocity of the electron. So this is in classical theory or classical model of atom. Now we know that nucleus has a charge. If it is a charge ZE, okay, so there will be magnetic electric field which we can write as ZE by 4 pi epsilon naught is R ZE R bar by 4 pi epsilon naught R cube. Now we have to find the magnetic field. So that magnetic field you can write it as E bar cross V bar by C, that is speed of light. Now you can put the value of E bar as electric field into this equation. So this equation becomes ZE. Now we have the value of E bar as 4 pi epsilon naught. Then R bar cross V bar and denominator I. So this is the magnetic field due to this nucleus or due to the total atom. From equation 1, let's say this is the equation 1. Here electric field as take 2. Now from equation 1 you can write H as H here ZE. Z is atomic number, you know this. Now R bar cross V bar we have it here. So let's put the value of R bar cross V bar. Okay, R bar cross V bar has the value L star H divided by, it is 2 pi m and remaining height. Okay, so here you can write 4 into 8, and of course pi square. So this will be the magnetic field. Magnetic field. Here we just forgot our C. Okay, so that C will be here. Now this is magnetic field H bar. Now electron precesses in this magnetic field. Okay, it spins, it orbits in this magnetic field, it precesses, revolves around this magnetic field. That is called precession of its of electron. Okay, precession of electron around this magnetic field. Magnetic field H, if it is the direction of H, then this electron will revolve or precess around this resultant magnetic field. So this is called precession. Okay, so this precession, to calculate the velocity, the precessional velocity, we have to calculate first, we know. Now, I will write this out. To calculate this precessional angular velocity, we know that mu has spin, the magnetic moment due to the spin of that electron. Okay, electrons spins, so it has magnetic moment mu s, that is EH by 4 pi m c. So it is magnetic moment due to the spin of that electron, that is mu s. Okay, now if you want to calculate the omega f, that means it is an angular precessional velocity. Okay, not total, there is a relativistic velocity also, angular velocity. So yes, we will calculate this. So what is the formula? We have magnetic field multiplied with magnetic moment of the spinning electron and divided with mechanical moment of that electron. So we know here magnetic field H, magnetic moment of E, that is this, mechanical moment we know, I will write it here. So here omega L will be this magnetic field H bar cross the magnetic moment of E, that is EH by 4 pi m c divided with mechanical moment. Consider here we have mechanical moment as S dot H by 2 pi. So this is nothing but S, total resultant spin, mechanical spin, which is nothing but we know it is an half. Okay, we know the electron's mechanical spin is half. Okay, we have the value of H, but we will put it later because we just have another additional velocity term, that is just short term omega L will be H. This is you can see here this 4 is pi goes H goes, it is nothing but H by MC. Now we have another additional velocity which is relativistic velocity of electron, relativistic angular velocity around that magnetic field. So we have to add that one also, but it is, what is its magnitude? It is half of that omega L, but in opposite direction. So that will be half of omega L, sorry, it is omega P, you can say that relativistic velocity is half of that omega L, but in a negative direction. So when we add these two, then we add omega L plus omega T, we will get, this is full, this is half, it is minus sign, so when we add them, we will get half of omega L, which is nothing but Ht by 2mc. Okay, so that is resultant omega, which is nothing but angular precessional velocity, or we can say Larmor precessional velocity, which is nothing but He by 2mc. So this is H. We have to put the value of H here. Let's see what happens with omega H bar Z E. There is another E, so E square L star H by, here we have 8 into 2, that will be 16 pi square epsilon naught m square c square r cube. So this is Larmor precessional velocity. When the electron revolves, precesses around the magnetic field, we can call it as a Larmor precession. Okay, so that velocity, that angular velocity, is also called as Larmor precessional velocity or angular velocity. See, that special velocity, special angular velocity, we will call it as a Larmor precessional velocity omega. We know the interaction energy is product of Larmor precessional angular velocity. The interaction energy del W is nothing but, it is the product of Larmor precessional angular velocity and, that is omega, and the projection of spin angular momentum, that is S star, on the L star, that means the orbital angular momentum. So precession of this vector onto this is, there will be some quantity, and their product, that means this quantity, the projection of S star on L star, this quantity and product of this quantity, that means interaction energy is not, Larmor angular precessional velocity. The product of these two is nothing but the interaction energy del capital W. Okay, so here how we will write the projection of one vector quantity onto another? We use that cos angle line. So S star x by 2 pi cos of S star L star. So you know this term, it is angle between S star and L star. So this is how we write the projection of S star on L star. Okay, so this is projection of S star on L star, that is spin angle, projection of spin angular momentum vector onto the L star, that is vector of orbital angular momentum. Now here the interaction energy capital del W is nothing but the product of Larmor angular precessional velocity and the projection of S star onto L star. How we measure the S star, the projection of S star or the projection of any vector quantity onto another, like this. We know this, we take the angle and this quantity. Okay, so here we can put simply the value of omega here and compare our result del W will be, what is omega? Here Z, I can write Z E square L star, here is S star, so I will write S star, L star, then H, here is H square, again cos S star, L star, that angle between S star and L star, then 16 into 2, that will be 32, pi square, here is pi, so pi cube, then epsilon naught, m square, c square, r cube. So that will be the interaction energy of spin orbit interaction.